Addition is one of the four basic operations of arithmetic, with the others being subtraction, multiplication and division. The addition of two whole numbers is the total amount of those quantities combined. For example, in the picture on the right, there is a combination of 3 apples and 2 apples together, making a total of 5 apples. This observation is equivalent to the mathematical expression 3 plus 2 equals 5, i.e., 3 add 2 is equal to 5. Besides counting fruits, addition can also represent combining other physical objects. Using systematic generalizations, addition can also be defined on more abstract quantities, such as integers, rational numbers, real numbers and complex numbers, and other abstract objects such as vectors and matrices. In arithmetic, rules for addition involving fractions and negative numbers have been devised amongst others. In algebra, addition is studied more abstractly. Addition has several important properties. It is commutative, meaning that order does not matter, and it is associative, meaning that when one adds more than two numbers, the order in which addition is performed does not matter. Repeated addition of 1 is the same as counting. Addition of 0 does not change a number. Addition also obeys predictable rules concerning related operations such as subtraction and multiplication. Performing addition is one of the simplest numerical tasks. Addition of very small numbers is accessible to toddlers. The most basic task, 1 plus 1, can be performed by infants as young as 5 months and even some non-human animals. In primary education, students are taught to add numbers in the decimal system, starting with single digits and progressively tackling more difficult problems. Mechanical aids range from the ancient abacus to the modern computer, where research on the most efficient implementations of addition continues to this day. Notation and terminology. Addition is written using the plus sign, plus between the terms, that is, in infix notation. The result is expressed with an equal sign. For example, there are also situations where addition is understood, even though no symbol appears. A column of numbers, with the last number in the column underlined, usually indicates that the numbers in the column are to be added, with the sum written below the underlined number. A whole number followed immediately by a fraction indicates the sum of the two, called a mixed number. For example, 3½ equals 3 plus 1/2 equals 3.5. This notation can cause confusion since in most other contexts juxtaposition denotes multiplication instead. The sum of a series of related numbers can be expressed through capital sigma notation, which compactly denotes iteration. For example, the numbers or the objects to be added in general addition are collectively referred to as the terms, the addends or the summands. This terminology carries over to the summation of multiple terms. This is to be distinguished from factors, which are multiplied. Some authors call the first addend the addend. In fact, during the Renaissance, many authors did not consider the first addend an addend at all. Today, due to the commutative property of addition, addend is rarely used, and both terms are generally called addends. All of the above terminology derives from Latin. Addition and add are English words derived from the Latin verb addere, which is in turn a compound of add, to, and ere, to give. From the Proto-Indo-European root *d, to give, thus to add is to give to. Using the gerundive suffix nd results in addend, thing to be added. Likewise from augur, to increase, one gets addend, thing to be increased. Sum and summand derive from the Latin noun summa, the highest, the top, and associated verb summary. This is appropriate not only because the sum of two positive numbers is greater than either, but because it was common for the ancient Greeks and Romans to add upward, contrary to the modern practice of adding downward, so that a sum was literally higher than the addends. Addere and summary date back at least to Boethius, if not to earlier Roman writers such as Vitruvius and Frontinus. Boethius also used several other terms for the addition operation. The later Middle English terms, addon and adding, were popularized by Chaucer. The plus sign, plus, is an abbreviation of the Latin word a, meaning and. It appears in mathematical works dating back to at least 1489. Interpretations. Addition is used to model countless physical processes. Even for the simple case of adding natural numbers, there are many possible interpretations and even more visual representations. Combining sets. Possibly the most fundamental interpretation of addition lies in combining sets. When two or more disjoint collections are combined into a single collection, the number of objects in the single collection is the sum of the number of objects in the original collections. This interpretation is easy to visualize, with little danger of ambiguity. It is also useful in higher mathematics. For the rigorous definition it inspires, see natural numbers below. However, it is not obvious how one should extend this version of addition to include fractional numbers or negative numbers. One possible fix is to consider collections of objects that can be easily divided, such as pies or, still better, segmented rods. Rather than just combining collections of segments, rods can be joined end to end, which illustrates another conception of addition. Adding not the rods but the lengths of the rods. Extending a length. A second interpretation of addition comes from extending an initial length by a given length. When an original length is extended by a given amount, the final length is the sum of the original length and the length of the extension. The sum A plus B can be interpreted as a binary operation that combines A and B, in an algebraic sense. Or it can be interpreted as the addition of B more units to A. Under the latter interpretation, the parts of a sum A plus B play asymmetric roles, and the operation A plus B is viewed as applying the unary operation plus B to A. Instead of calling both A and B addends, it is more appropriate to call A the addend in this case, since A plays a passive role. The unary view is also useful when discussing subtraction, because each unary addition operation has an inverse unary subtraction operation, and vice versa. Properties. Commutativity. Addition is commutative. One can change the order of the terms in a sum, and the result is the same. Symbolically, if A and B are any two numbers, then A plus B equals B plus A. The fact that addition is commutative is known as the commutative law of addition. This phrase suggests that there are other commutative laws. For example, there is a commutative law of multiplication. However, many binary operations are not commutative, such as subtraction and division, so it is misleading to speak of an unqualified commutative law. Associativity. Addition is associative. When adding three or more numbers, the order of operations does not matter. As an example, should the expression A plus B plus C be defined to mean plus C or A plus that addition is associative tells us that the choice of definition is irrelevant. For any three numbers A, B, and C, it is true that plus C equals A plus. For example, plus 3 equals 3 plus 3 equals 6 equals 1 plus 5 equals 1 plus. When addition is used together with other operations, the order of operations becomes important. In the standard order of operations, addition is a lower priority than exponentiation, nth roots, multiplication and division, but is given equal priority to subtraction. Identity element. When adding 0 to any number, the quantity does not change. 0 is the identity element for addition, also known as the additive identity. In symbols, for any A plus 0 equals 0 plus A equals A. This law was first identified in Brahmagupta's Brahmasphata Siddhanta in 628 AD, although he wrote it as three separate laws, depending on whether A is negative, positive, or 0 itself, and he used words rather than algebraic symbols. Later Indian mathematicians refined the concept. Around the year 830, Mahavira wrote, 0 becomes the same as what is added to it, corresponding to the unary statement 0 plus A equals A. In the 12th century, Bhaskara wrote, in the addition of cipher, or subtraction of it, the quantity, positive or negative, remains the same, corresponding to the unary statement A plus 0 equals A. successor in the context of integers. Addition of 1 also plays a special role. For any integer a, the integer is the least integer greater than a, also known as the successor of a. For instance, 3 is the successor of 2 and 7 is the successor of 6. Because of this succession, the value of a plus b can also be seen as the successor of a, making addition iterated succession. For examples, 6 plus 2 is 8, because 8 is the successor of 7, which is the successor of 6, making 8 the second successor of 6. Units. To numerically add physical quantities with units, they must be expressed with common units. For example, adding 50 milliliters to 150 milliliters gives 200 milliliters. However, if a measure of 5 feet is extended by 2 inches, the sum is 62 inches, since 60 inches is synonymous with 5 feet. On the other hand, it is usually meaningless to try to add 3 meters and 4 square meters, since those units are incomparable. This sort of consideration is fundamental in dimensional analysis.